people. Oh my God. All right, let me see real quick. Ethan's not here. Ronnie's not here. And I got none of my VDs here. Kevin, good timing.
Thank you.
Okay. All right. Hey y'all, where are you? So, what's due tomorrow? What homework is due tomorrow?
All of it.
Everything through here except for 2.6. 2.6 we're doing later. So ready with me? This is really bad news for anybody who hasn't really been doing the homework. Because there's a lot of people that haven't given me anything yet, so that's interesting to me. So hopefully you've been doing it, and then it's not a big deal. You've just been doing it, so you're going to be ready. If you happen to be a person who is back here, maybe, or maybe back here, maybe, stop trying to do every problem. Because the worst thing in the world is to try to finish everything in a section and then you stop here and the test goes to here. You're gonna die on these sections questions, yes? You need practice. So at this point, if you're really far behind, just stop trying to do every problem. Do like every other problem or something. Just make sure you get enough practice from every section before the test. You guys with me? The main purpose of homework is to get you ready for the test. So it's like if you don't do every single problem, that's not a big deal. I'm still going to say finish this. What in the world? Sure. But you do what you can. Oh my goodness. Adobe, go away. Okay, I think I closed out too much. You guys go with me? So everything through 5.1, except for 2.6. Homework's too far. But just turn in what you can. Yes? Just come ready. Just. Okay. Now that more people have come, anybody else need a copy of the practice test? Did everybody get a copy of the practice test? Okay. Let me try to give back some more stuff here. Ethan is still missing. Joey's been missing. Ronnie's not here. I've got my keys. I think this is the new stuff here. Is that true? Who's this? Is that you? Me? And then Wikipedia. So, obviously, I've never had any of you for class before. So this is the first time you are having a test review with me. So, I was considering, let's just feel today out. I'll start with questions from people. And if I'm not getting enough questions, then I'm gonna have you guys work on specific problems from the practice test together, like up on the board. I'll kind of get some freaking whiteboard markers in case we go that way. We'll see. But today is wide open. You can ask questions from homework, you can ask questions from quizzes, you can ask questions from the practice test. You can just make up questions. You can just say, can you do an example of this kind of question? It's wide open, whatever you guys want to talk about. Right? Tomorrow is the test, of course. Okay. So it really kind of depends on what you want to focus on. There were a ton of problems on this practice test. The actual test won't be quite this long, but it will have most of this on it. So is there a place we want to start? If nobody's asking questions, the floor is totally yours.
Can we go over 1B?
Sorry, which one?
1B?
B is in boy?
Yes.
Okay. So, what do you guys think about this problem? Could I, like, cancel a couple X's out here?
Yeah.
No. Real quick. Could I reduce this fraction? Even though 8 is 5 plus 3? Of course not, right? Because I can only cancel common factors. Because division is the opposite of multiplication, and the bottom is adding. So division can't cancel addition. So do you see how every term in this on the bottom are subtracting or adding? So division can't do shit. If only I could somehow rewrite everything so that they are multiplying, then division could potentially cancel something. Because what's division's job? To cancel multiplication. So can I rewrite them into stuff that are multiplying?
Yeah.
How do I do that?
X times X times X minus.
Yeah, so this is a cube, so now you factor the top and bottom, right? So you guys with me? So if you factor the top, in fact, that's what we do. How do I reduce 5 25ths? You factor. Now, of course, you don't do this, but you do this. How many 5s cancel? 1. 5 divided by 5 is 1, so I get 1/5. Now, normally we don't do this middle step. We do it in our head. We don't even think about it this way. But that's what we're doing. So when you have a fraction, the only way to simplify it is to maybe reduce it. And how do you reduce fractions? You factor and you kill the common stuff. Okay. How are we doing? I appreciate this. We filled out a little more. 2, 4, 6, 8, 10, 12, 13. Lucky 13. Is that okay? So here, can you guys, if you haven't tried this yet, can you try to factor the top and factor the bottom? Go for it. So in 1B there, try to factor the top, try to factor the bottom. So what kind of factorization do you use on the top? Yeah, cubes. So like you said earlier, XXX 333, little dude, big dude. What goes in the little tiny dude? Yeah, 1x. Yeah, same sign, minus. 1, 3, so these other two x's go x squared here. What goes at the end? What sign is this last one? It's always positive. And how do you get the middle term? What sign will it have? Opposite. Opposite of this one, yes. And then what goes here? 3x. Just whatever's in here, you just multiply them together. So it's 1 of each, 2 of each, product in the middle. That's the top. This is a very teacher problem because it's so many steps. I love it. What can I do on the bottom?
Do I have to do 2 times 24, blah, 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 blah? Do I have to? Why not? Why don't I have to do that? Because what can I do instead?
Take 2 out.
Take a 2 out. What am I left with if I take a 2 out?
X squared plus 2 is 12.
X squared plus
X.
x minus 12. And then I can factor this here, yes? Alright. So you do that one more step. How does this here factor?
X minus 3, X plus 1.
Yeah, you need 2 numbers that multiply to be negative 12 out to be 1. So it's got to be 3 and 4, and the 4 has to be positive. Does anyone see a common factor now? So I'm dividing. If I have multiplication, I can cancel parts of multiplication with division. I can never cancel parts of subtraction or addition with division. And we know this. The minute I wrote down 5 over 8, you're like, no, you can't reduce that. Look at the shit that 8's 5 plus 3. It's based on multiplication. So what can I kill? What dies? Yeah, x minus 3. Da. So then I'm just left with blah, 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 blah. Yeah, x squared plus 3x plus 9 over 2 times x plus 4. Kabam. So this is a first tier use of factorization. And I want you to realize, okay, this is kind of, x plus 4 is a number. X squared plus 3x plus 9 is a number, right? X cubed minus 27 is a number. So whatever I do with numbers, I do the same thing with those expressions because they are numbers. They work the same way, they have to. So I factor to reduce a fraction, so I factor to reduce a fraction. Doesn't matter what's in it. Okay. Alright. What do you guys, some of you guys have lived this. So I can understand if you answer this question from lived experience. What's the biggest mistake to make on this kind of problem? What are you supposed to do with this and this? You're supposed to subtract. What do you think some people might have done? Some people foil it, yes? Because your brain sees 2 parentheses and you're like, yeah, algebra, they want me to foil it. That's subtraction, it's not multiplication. Just distribute the negative, get your like terms together, right? Now, I understand this is our first review day. None of you have ever had me as a teacher before, so you don't understand how this is. You could ask literally anything related to what's going to be on the test. And from homework, from your own mind, you could just say this. You could just say, hey man, I forgot how to factor square. Okay, but hey, could you make up a problem like the weird ass the vertex stuff? Yes, I can. Yes. G. Which one, sorry? 2G? This one?
Yeah.
Okay. Alright, so is everybody cool with this is f of x, yes? That's f of x. So one thing is students, when I ask a question like this, they get a little confused. Some students will graph a line for me because they're not sure, but what is this? What would this look like related to f of x? What kind of transformations are happening? How many transformations? There's 3. What are they? Yeah, so what does this make it do? How would it move? Say again? Left 2. What would this do? How do you mean going down? What's it do? What kind of a thing is it? It's a reflection, yes? Alright, then real quick. If it's inside, it's left and right, yes? This is almost too good to believe. X-axis is left and right.
So if it's in with the x, it's left and right. That's why the +2, it's with the x, it's why it was left and right. It went left 2. If it's outside, it's up and down. So if it's a reflection up and down, it's going to turn this way. So it's going to reflect around the x-axis. It's going to be a reflection up and down. Okay, maybe like a reflection in a pond. Yes? So this will be a reflection x-axis. And what does this do? Up 1. So can everybody take a moment? In fact, let's identify. Can you guys see definitive points here? Do you see this point, this point, this point? We really just need like 3 points because we know the shape of it is a W. Can anyone tell me what letter it's going to look like at the end? An M, because it's gonna at some point it's gonna turn over. It's just where's that M gonna be? I've got to move points to figure out. Could everybody just take a minute and apply those transformations? I'll wait. Just do these things to that W. And you got 3 definite points you can move around. Flush. Flush, flush, flush. I understand being allergic to math. This is happening. There's no shot to take, I'm sorry. At least not that I know of. Have any of you guys, let me think, have I seen any of you guys? Have any of you guys ever, have you gone to the CISL yet for help? Yes? Because you know I'm in there like right when class ends. At least, I can't remember, some of you guys go there. So at 2:30 and it goes straight to the CISL. So I'm in there. So if you are tired of hearing me talk, you can just avoid that time. Just to remind you guys, I mean, if you're gonna do homework and you can be here, go to the CISL, get it knocked out. If you don't ask anybody questions, great. If you need help, it's right there. They're right there. Because it sucks when you're at home, you're trying it, ain't nobody near you that can help. You're like, oh crap. Okay, so if I take this point, how do I move it? What do I do first? Left 2. Bam, bam. Now what do I do? Are we doing okay out there? You guys okay? Is anyone doing this? Or are you just, what's happening? You don't want to say? I'm going to literally just do these 3 things to every point. So I'm going to move it back 2. What's the next thing I do after left 2? Sorry? I'm going to reflect it around the x-axis. So what would the reflection be? So I moved it back 2, left 2. Now I'm going to reflect it. The x-axis is a mirror. So where am I going to be now? Positive 3. Yeah, that's literally just the reflection. And then what's the last thing I do? Up 1. Bam! There it is. That's why you give yourself points, because if you just move the points, you're going to put the shape back on top. So you're like moving the skeleton and then putting the, that's horrible, putting the flesh in this term. So then if I take this point, I'm going to go left 2, 1, 2, reflect it around the x-axis, and then up 1. This point, 1, 2, I'm going to reflect it, and then I'm going to go up 1. And now we said it should look like an M, so I'm going to go we, and that's good. Just put little arrows on the ends. You guys with me? Sort of? Okay. So if you list, so trust me, if I ask you a question about transformations, you must list the transforms. You must have the base function graphed, and then you just apply the transforms. Is that okay? Who asked that question? Did you ask it? Is that okay? Okay. And again, just if we do a problem and you're like, I don't get it still, can you do another example? Yes, I can. Today's wide open. Wide open. Whatever you want to talk about. And if I'm not getting enough questions, then I'll put you all together and work on some specific problems. So we'll see. Go for it. What we got? 3.7. Which one? 11? I love it. Alright, so this one here, yeah? Okay, so again, I'm going to copy that problem over here. Which one? 11, there it is. Y equals x over x plus 2. Okay, so we're going to do number 11. If I want to find the inverse of a function, algebraically, graphically, what do I do? Switch the x and y. Every x I make it a y, every y I make it an x. And then let's see, let's do this first. So if I switch the x and y, it's really unfortunate for me that I can't make a y. It's kind of a major letter. Too bad for everybody. And then I do what? I don't circle that shit. I don't know the inverse yet. What do I do? Just in general, what do you do? I'm trying to find the inverse. I switch the x and y, and then okay. Here, let's try a simpler function, yes? What if I gave you this function here? Switch the x and y, and then I do what? What do I do now? What's happening? Y, yes, say it. Multiply by what? Because what are you going to do? Why would you multiply by 3? What are you trying to do now? Trying to get y by itself. Solve for y, yes? Now listen. There's a process for finding the inverse. That process cannot change. It cannot change. Now, I can feed it different things, and depending on how gross the function is, I as a human have to do different shit. But the process says, switch the x and y, solve for y. That's the process. And then I do whatever I have to do to make that happen. Here, this is easy. You multiply by 3, so you kill the fraction. Die. And then what? Add 1 and then divide by 2. Is that cool? So that would be the inverse. So over here, I know it looks weird. I need you to not care. What do? We do the exact same thing we did over here. What do I do? What's the first thing I do? You can do it. Yes, multiply by y plus 2. Because what is the worst thing about this equation? A stupid fraction. So I'm going to multiply by the same thing we did over here. Exactly the same thing for exactly the same reason. Y plus 2. Multiply this side by y plus 2. So over here, these die. And over here, I get xy plus 2x. Now, I'm going to do the same thing I do every time. Try to take over the world. How many y's are there? 1. Good. Look at you. I probably said this already, or you're just nifty. There's only one y. Now, I'm cool with it if you say there's 2, but there really is just 1. How do I see that there's 1? Well, what do you do? How do you always solve for a variable? You get all your
blah, 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 and then everything else will. How do you solve for x in an equation? No, I know I'm not solving for x, but just go back in time. How do you solve for x? You get everything with x in it on one side, everything else on the other side. So what letter am I trying to solve for? Y. So I have to get everything with a y in it on one side, everything else on the other side. We know that's how we solve equations. So what's the one thing that's in the wrong place? Huh? The xy is in the wrong place, right? If I move this, then all the y's are on one side, yes? So I'm going to get all my y's together. And now you're going to see that there's only one y, because what could I do now? Do it again. No, I'm not trying to solve for x. No, because I got all my y's together finally. Divided by x won't do shit for me. Take a y out. Take a y out. Don't these both have a y? Don't they both have a y? If I take a y out, what's left? What's y divided by y? What's y divided by y? And what's xy divided by y? Yes? Yes? I'm one step away. How do I get y by itself? What do I want to get rid of?
Right back on
Yes, it's times this shit. I don't want that shit, so I divide by it. Did we get y by itself?
Yes.
So this would be f inverse. Did you guys see that? Whenever you have, and you've done this before, whenever you have more than one variable, you get them all together on one side, and then you almost always divide at the end. Yes? This one was different because they're not like terms. But if they're not like terms, you just factor a y out. Here. How do you solve this equation here?
Back to 3x.
I don't want to hear anything about 3. He's fine. What's the only thing in the wrong place? Where are my numbers? They're on this side, yes? Aren't all my numbers over here? So where should all my x's be? Other side, yes? So what's the only thing in the wrong place? Alright, so what do I do?
Back 4x.
I'm going to do something really weird. There's no reason I should do this, but I just want to show you. Could you take an x out of here?
Yeah.
What is 3 minus 4? So that's negative x. Now, of course, 3x minus 4x is negative x. But it is kind of cool to realize, oh, it's just because I can take an x out and then I just got numbers. And then divide by negative, what am I trying to solve for? I forgot already. Oh, divide by negative 1 to solve for x. Yes? Okay. So, I mean, where'd that y come from, Jeff? That's a great question. I don't know why I put a y here. It just suddenly showed up. So we divide by negative 1, I get x is 7. Shoo. So we've done this stuff before. Okay. So, just to kind of give you an idea, you could ask, hey man, could we do several more of those? Or you could do something else. What you got?
Can we go over number 5?
Sure. Okay. So here's an example where I did not give you the function, so you have to first graph the base function. Yes? So if you haven't done this yet, tell me first how many transformations there are. 2. What are they?
Inverse x.
What does that mean, inverse x?
It means
I'm going to reflect.
flip over the y-axis.
Yes. Because, real quick, what is it? If it's inside, it's left and right. Yes? Because inside is x and that's left and right. If it's outside, it's up and down. This is inside, so it's got to be a left and right reflection. I'm going to reflect it this way. So around the y-axis. And then what's the other transformation? Down to. If you could identify the transformations, you can tell me what the function was before they did either one of these. What was this originally?
Square root of x.
That's what I mean by base function. Yes? Base function is just the function that somebody wants me to move. Somebody wants me to do those two things. So if I take them out, I see, oh, it's the square root of x. Can you guys do it a dotted base function? Yes, graph y equals square root of x. And then try to move the points.
Yeah.
Do it. I'll just stand here. Or I might move around.
Sorry, I'm feeling a little sick right now.
I got you. Alright, so the base function, can somebody tell me the 3 points that we can use for the base function? What does square root of x go through? Yeah. 0, 0, 1, 1,
4, 2.
4, 2. So I'm going to use nice whole number points, of course, right? It obviously goes through a bunch more points, but I'm not going to use those. I know the shape of it, and I just need a few anchor points. Each point, pick a point and do those two things. So this point's kind of funny for the first thing. If I reflect this guy around the y-axis, what's he do?
Stay.
Stays there. And then I have to take him down 2. So he's there now. What about him? Reflect him around the y-axis. So this is the mirror now. So where would the reflection be?
-1.
Here, is that cool? And then I,
Do down
1, 2. Take him. If I reflect him around the y-axis, where does he end up?
2. -4, 2.
Yeah, 4 back this way. And then I go down 2. Then I put the shape back on. Done. How can I check this? Be great if I knew how to check this shit, Jeff, before turning it in. That'd be amazing.
Put your points into the
Yeah. What point is this?
-1, 1.
-1, -1. So if I put a -1 in, what's -1? I'm putting a -1 in for x, right? So what's -1? 1. Square root of 1 is 1 minus 2. 1 minus 2? -1. So when I put a -1, I got a -1 out. I feel pretty good. It would be a really big coincidence that that point works and I got the rest of it wrong. So I feel pretty good. Now what sucks is if you do the check and you make a mistake with the check math and you think you're wrong, so be careful. You guys at all with me? So sometimes students don't trust transformations. I'm not going to say that they feel too easy, but it's the fact that it doesn't matter what the function is. They always work the same way. You just have to know the shape of the function. Why don't we, all right, here. I have an idea for what to make you guys do, but I want to first make sure. Anything else you specifically want to talk about?
40.
4D. I thought you said 40. I'm like, how long did I make this? 4. Oh yeah, look at that one. That's yummy. Let me ask you a weird question. Do you agree? Well, first off, how many terms are in 4D? How many terms are there? Yeah, I heard it. 2. There's 2 terms. Good. Do both terms have a number?
Yeah.
What letters do both terms have? What variable stuff do both have? They both have some number of A's, and they both have some number of
X.
Neither one has a single X, and neither one has any X's. What do they both have? A certain number of X minus 1s. You can see. So they both have some numbers, they both have some A's, they both have some X minus 1s. So how much of each can I take out? So look at the numbers. Numbers are nice. What number can come out of 9 and 12? Do it again. 3. How many A's can I take out?
2.
Say again. Yeah, I can take 2 out. How many X minus 1s can I take out?
2.
2. I'm gonna make it a bracket just because. 9 divided by 3.
Brackets.
9 divided by 3 is 3. I had 2 A's, I took them. I had 2 X minus 1s, I took them. You guys with me?
Yes.
Plus 12 divided by 3. 12 divided by 3.
4.
4. I had 5 A's, I took 2, so now I have
8 to
3. And I had 3 X minus 1s, I took 2, so now I have. Do you guys see what just happened? You can do exactly that. You just do it step by step, numbers and then variables as they come. And there is no X here, there are X minus 1s. And now what's the only thing I can really do that actually doesn't even matter? How can I clean up that inside?
But the
Yeah, that can distribute, but you know, nothing's really going to be like terms, so it almost doesn't matter. You normally do that just in case there's like terms on the inside. Okay. Any problem we're doing, you could say, hey man, could we do like 2 more like that? That's a thing you could ask. Anything. Because I have the key for this. I've already done these. I'm going to give that to you. You can see how these are done. So you could say something like, hey, can we do one like this? Can we do one like that? Can we do 3 like this? If nobody's asking questions, the floor is yours. So
could we do one harder?
harder, yeah, sure. What do you got, Jeff? I don't know, man. Oh yeah, let's do this. Ask and you shall receive. Now, what's the one thing that's harder? Do you guys see? Like, the more you understand what I'm about to say, the more you understand that we're doing the exact same problem we just did. But what is the most obvious major difference? Not it was 9 and now it's 24. It's just a number, right? And instead of A's, I got W's. Yes. So what is the one really kind of fundamental difference?
Fraction.
Fractional powers.
Yeah.
You with me? But they work the same dumb way. Why did you tell me to take out, where did I put it here? Why did we take out 2x minus 1s? Why didn't we take out 3?
Is the other way.
Because the other guy can't handle more than 2.
Yeah.
So what do we always do? We take out the power that is the
Slowest.
smallest, yeah. So let's go this one at a time. What number could come out?
4.
4. How many W's can I take out?
4.
4. How many 2b minus 1s will we take out?
1/5.
Yeah, the smaller power, which is 1/5. Okay. So everybody with me. The more you see that this is the exact same problem we just did, are some of the numbers worse?
Yeah.
Yes, some of them are freaking fractions, Jeff, you freaking math person. But I'm gonna do all the same shit. Why did I put a first power here? Because what's 3 minus 2? 1. So that's why there was 1 left, yes? So here, in the first piece, 24 divided by 4 is 6. I had 5 W's. I took 4. 5 minus 4 is 1 W left, right? And I had 1/5 2b minus 1s, and I took 1/5 2b minus 1s. So is there anything left here? Nope. Minus 20 divided by 4 is
5.
I had 4 W's and I took them. I had 6/5 of these. I took 1/5 of them. So how many 2b minus 1s are left?
1.
6/5 minus 1/5 is 5/5 is 1. We did exactly the same thing we did before. And then the last thing is just to clean up the inside a little bit. Is that cool? Just in case there's lecture. There won't be, but you still clean it up a little bit. Distribute the -5. Is that cool? So I could make the powers worse. I could do it, but it doesn't change the process. You take out the smaller power, you see. Okay. What's a little more important than this is really just GCF, is like the forms of factoring. So make sure you can do these. We can do some of these if you want. Up to you guys. Or is there anything else, somebody else is thinking about? Say again. 4A? Is that what you mean? This one? Okay. What would you guys do first on 4A? Does that third power mean it's a cubes? Cubes is something very specific. How many terms in order for it to be a cubes or squares? 2 terms. Does this have 2 terms? No. In fact, you can't cut everything in there in thirds, and it's more than 2 terms. It's not cubes. But what do you always do first? What do you always look for first? GCF. Cool. That will save your ass. Don't forget to look for GCF. Holy shit. Sorry, that was neat. So don't forget to look for GCF first. It's going to save you from yourself. What can come out of 4A? What can come out? What do they all have?
X.
They all have 1x. Some have more, and that's good for them. So take an x out. What are you left with?
Squared minus 5x minus 66.
And now this looks like a classic trinomial dude. Yeah. Sorry, I think a bird just flew right by. That's true. Yes? Find the numbers that multiply blah blah and add with blah blah blah.
You guys remember? 6.
Yeah, you hear that? What's the 2 numbers that work? What's the 2 numbers that work? You need 2 numbers that do what? What about? You need 2 numbers that do what? Multiply to be negative 66. And? Add to be negative 5. And thankfully, the most obvious way to factor 66 is what? 6 times 11. And if you make one of them negative, you can make negative 5 out of it. Yeah. You guys okay? So I can't stress this enough. Christine can attest to this. The more you can factor, the easier time you're going to have in calculus. In fact, I mean, you're not going to take, well, I don't know, maybe some of you guys are going to take business now, but the reason people do really poorly in business calc, and to some degree why they do poorly in calculus, is because they can't factor. And factoring shows up probably more often than you think it's going to. Am I full of shit? You never know. I could, yes? Okay.
No, you're not. No, yes, it comes up all the time.
It comes up all the time. So, oh my God, you gotta trust me. That's why at the beginning when I teach calculus, I always have a little bit of a time just reviewing factoring, because it's just gonna come up. So the more you go into that with your factoring under your belt, you're gonna immediately have a much easier time. You just consider like doing limits, right? So this is, yeah, anyway, you'll see. So what were the two numbers again? Sorry? 11 and 6, and which one's negative, so I can make the middle term negative? Yeah, the 11. There you go. So don't forget your GCF first, because otherwise, if you don't take a GCF out, people do really weird things. For example, look at 4B. What do you do with 4B? How many terms does it have? So is it a cubes or a squares? So you can cut y in thirds? No, so it's not a cubes. It could be a cubes because it's two terms, but it's not, because I can't cut 6 in thirds. And I don't mean additively, I mean multiplicatively. What number times itself 3 times is 6? I don't freaking know. Yes? You with me? So that ain't a cubes, but of course, what did we just bypass? That we should always try first. What do you always try first? GCF. Yeah. Is there a number that comes out? 6. Is there anything else that comes out? Y. Good. So what's left here if we take the 6 and the y away? W to the third. 48 divided by 6 is 8. I had a y and I took it. Bam! Now what's this?
Cubes.
That's cubes. Totally, because they can cut everything in thirds. So then little do, big do, blah, 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 blah. So be really careful. You guys know me by now. If I ask you to factor, you know that at least one of them is going to be multi-step. So just because you get one thing to work, don't stop. Don't leave it alone. Look at it again. We uncovered a cubes. Let's do a cubes, yeah. So, anything else specific?
Can we do 1F?
1F?
Yeah.
Oh yeah. So let me show you a few different ways to do that. I'll show you the way I showed you. Does anyone remember the way that I said to do these? I love you guys. You're all like, we don't listen to you, man. You're always up there just talking all the time. Huh?
Divide by 4.
Yes, because every fourth it starts over again. So if we can just figure out how many full rotations it's done, I can take those out the way. So there's a few different ways to do that. 4 goes into 33. I don't care how many times. Remainder what?
1.
And how do you know that? Because what's close to 33 that's underneath it that 4 goes into?
32.
32. So I could write this as I to the 32 times I. This is 1. Because it's 8 rotations. And it always comes back to 1. So if I rotate 8 times, I'm back to 1. And then this says, oh yeah, go I more. So I get 1 times I. Or 4 goes into 33, remainder 1. So this is equal to I to the first power. I. Or I to the 32 times I. This is I to the 16 squared times I. That's just a weird way to do it, but just in case. Even better, I should make this I squared to the 16th. There you go, turn around. I squared is negative 1 to the 16 is positive 1 times I is I again. That last way I would not recommend, but it does work. It is just because it's cyclic. Every 4 it comes back. So 8, it's back. 12, it's back. So I got 13, that means it went 3 times and then 1 tick more. So that would be I did the first. So the remainder tells me where I am in the pattern. This is really cool because there's a whole class of math objects that are cyclic in nature. They're periodic. And some of them we're going to talk about later this semester. Good old sine and cosine. Sine and cosine, you're just like, oh yeah, just keep doing the same thing forever. Okay, poor little guy.
So what if we had like I-34 instead of 33?
Oh! If I add I-34, one way to look at this again is 4 goes into 34. Who cares? Remainder 2. So this is the same thing as I squared, and I squared you're supposed to have memorized. I squared is -1. But you see how it's built. One level of the skill is, do you remember to divide by 4? The fact that it's a cycle of 4. The second level of skill is, do you remember your values? What's I to the first? What's I squared? What's I cubed? Of course, I to the 4th is 1. It starts over again at that. Yeah.
And would there ever be such thing as like I to the 0th power?
Yeah, of course. What's I to the 0? If I start at 1 and I don't rotate at all, I'm 1. Yes, that's the absence of rotation. Yeah. In fact, we know that anything to the 0 power is 1. Yeah. Okay. So she already got her key. If you do have to leave early, just let me know so I can give you an answer key. Okay. So what I want to focus on is number 7. Nobody's asking me about number 7, so I want to look at number 7. Let me see. Do you guys know what I mean when I say use the shortcut? Does anyone remember what the shortcut is? Do it again. Negative b over 2a. Yes. But what's the long cut? Because obviously I said state the vertex, then I said use the short. So you can't use the shortcut to get the vertex. What do I have to do to this so I can just see the vertex? What do I have to do? No, that would give me the x-intercepts. Say again? Complete the square. Kick ass. Alright, so let me do this. I really want to make you guys do this. Let's do an example like this. So if I had blah 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 blah. Yep, plus 5. Sure. So to complete the square, I'm gonna make some room. Now can I do half of 12 squared? Or what's wrong? Anything wrong? Anything wrong? Say again? Yes, this is supposed to be 1, so what can I do to make this become a 1 in front of x squared?
Take out a -6.
Take a -6 out, yes? What am I left with then?
X squared minus.
Yeah, 12 of my -6 is -2x. Alright, now I can figure out. So what are the steps to completing the square for the inside here?
1 squared.
Yeah, half of -2 is -1. Squared is 1. The minute I put plus 1 down, did I actually just add 1 to the equation?
You took away 6.
I subtracted 6, yes? So what do I have to do at the same time?
Minus 6. Or add 6.
I always go the wrong way. It's okay, Jeff. Yes? We did this.
That's
Because, for example, there's no -2 in the equation, there's a 12. And sure enough, that's a 12. That's 12. So if I put a +1 there, I actually just subtracted 6. That's a -6. So what I have to do at the same time? Add 6. So if I put that together, how do I factor this? And that was really just, what's the first step? Half of -2 is -1. What's the vertex? I think I hear it. I think I hear it. 1, 11. Right 1, up 11. Can somebody tell me what the y-intercept is? I don't want to use this here, do I?
5?
Yeah, 0, 5. So if we make x 0, I get 5. So can you guys, please, do the same process to number 7? I'll leave this up here. Figure out the vertex, put it into vertex form, figure out the vertex, figure out the y-intercept. Here's some old handouts, but like everybody should have the completing a square handout from a while back. Does anyone need the putting quadratic functions into standard form? That's what we're doing right now. Has everybody got those? Okay.
If not, are those available online?
I mean, I got them right here.
I
I always forget.
think I have.
I could put them up in Canvas if I actually sit down and do it. I don't think about it. So going back here, what do you guys have to do first here? 2 things you could tell me.
Take 3 out.
Yeah, I could take a 3 out, and I could also make some room, yes?
Yeah.
The big mistake I see people make is they try to take a 3 out of this also. Just move him over. You don't give a shit about it. Put him over there. Get him out of the way. It's just the X stuff that I care about. Now, what are the 2 steps to complete the square?
That's
Yeah, take half the middle dude, which is -2. So the first step is half of -4, and then you take what you get and you square it. What does this tell me? What do I do with him?
And then see. Wait, you square that. Wait.
No, I already squared. What do I do with him?
Take away 12.
I'm gonna add it here. What did I actually just do? What did I just, I didn't add 4. What did I just do?
Add 12.
I added 12. So what do I have to do at the same time?
Take away 12.
Subtract 12. So overall, I just did nothing. Yes? I did not change the problem. It's still the same exact problem. How does this guy factor?
X minus 2.
Yeah, it's always the first step. X, and then put the first step down. Squared. So what's my vertex?
2 negative 7.
And what's my y-intercept?
5. 0, 5.
Yeah, 0, 5. Again. So go ahead and try to plot it. I'm pretty sure I told you guys how to find a point by reflection, a point by symmetry. We'll see. You should be able to get 3 points. The vertex, the y-intercept, and one more point that you don't have to do any work for. To graph this, so go for it. By the way, pick a good scale, yes? You shouldn't use a scale of 1 on your y-axis. You see why? What's your vertex? 2, -7. So how far down do you have to be able to go? 7 down. So I don't want to use a scale of 1 on my y-axis. Hey man. So if I use a scale of 2, let's say. So now if I plot my vertex 2, -7. By the way, is this going to open up or down? It's going to open up because it's positive in front of the x-bar. Good. My y-intercept is 0, 5. So can anyone figure out where there's a third point that I don't have to do any work to get? Not real work. This is the vertex, yes?
Reflected over the.
Yes. So the mirror is going to be right here. So there's a point here. There has to be a point there. Reflection point, yes? So you could even, if you wanted to, you can draw in your axis of symmetry. So you can see this is 2 away here, so 2 away here, there's a point right there. And now you've got your full parabola. Yeehaw. Yeehaw. How do you check your work? This is the point 4, 5. If I plug in a 4, 3 times 16 is 48, minus 12 times 4 is 48, 48 minus 48, 0 plus 5 is 5. So I get a 5 out when I plug a 4 in. It works.
So can we go over again how we get the y-intercept out of all the equations that we did for number 7?
Yeah, we did a smart thing. I could, how do you get the y-intercept always? What do you always do to get the y-intercept? You make, how do you, make x 0. I have 2 functions that are the same. This function and this function. They are the same. So I could put a 0 here and then do the work. I'd rather put a 0 here, because what do I get when I put a 0 in for x? What do I get? Get freaking 5, right? So 0, 5, done. Now let's check. If I put a 0 here, what's -2 squared? 4 times 3, minus 7. You still get 5, but it was more work, and it was easier to make a mistake. And normally what I get is somebody will tell me it's 0 and -7 because you just look at this number, but it's not what you get. It's only the number I see if everything else has an x in it. But that term didn't have an x in it, so it would still be left alive if you made x 0. Oh shit. You guys kind of with me? Maybe. Somebody tell me. Here, let me push this. Can somebody tell me what's the x-intercept for this? Almost.
0.
0, negative 2. Sweet. Sorry, man. Y-intercept is a point. So 0, negative 2. Yeah. Yes? It don't matter. It don't matter. It don't matter. Look, that's a gross number. Look at that. Look at that power. I don't care. I make x 0 to 5. All I need is a y-intercept. Make x 0, get the y-intercept. It'll be 0, comma, whatever I get. Let me push this one step further. Oh shit. You guys ready? We'll find out. Wait, I need something there. Can you guys get the W-intercept? I'll say this, I'll make it more specific. Can you get the W value of the W-intercept? You can do this, I know you can do this. How do I get the Y-intercept? I make the other letter 0, make x 0. How do I get the W-intercept?
Make everything else.
Make every other letter 0. So what do you get? What? You get W
Negative
equals,
1.
don't overthink it, make every other letter 0, correct?
Yeah.
So what's the only thing left alive?
1.
1. So W equals 1. Now, I'm not going to show you how to write the point, because the point would be in 1, 2, 3, 4, 5, 6 dimensional space. We won't go there. But the W value is 1. I make every other letter 0. Are you going to see a problem like this on the test? No. I just want to show you the idea extends throughout all of your math. It's going to be the same thing. Okay. Okay. So am I in control now? I mean, I don't want to be. Anybody? I guess I could be. I'm the teacher. Yes. 10B. Okay. Any suggestions on how to even approach 10B? To come out like this? All sneaky like. How would you even, oh, you guys have the blue line of death. It's not the blue screen of death, it's the blue line. So what I mean by that is there a general first thing you want to do? How would you even start to try to solve this thing? Yeah, why? Are all my x terms like terms? No, they all have different powers, correct? Okay, so when you see your x's having different powers, there are two things I want to do. No. No, I wouldn't start to factor now, because what's it not equal to that it needs to be equal to? If I want to factor it and get answers. No, come on. It's not equal to 0 yet. So, what two things do I want to do? When I see x's with different powers, what do I want to do? I want to get it equal to 0 and then factor. Yes? All right, go for it. So, just do the first step. So to get it equal to 0, you subtract x and add 100. Then you can put your like terms together. And I think I heard somebody say, once you put your like terms together, how many terms do you have? Right, you put the negative 24x minus x. Put those together. So do that, and then how many terms do you have? No. What are terms separated by? Minus and plus. So, once you put those together, you will have 4 terms. What do you do when you have 4 or more terms? What kind of factor in? Grouping. Yeah. So remember, the number of terms a problem has, if you know you're going to factor, that tells you what form of factoring to do. It's almost too good to believe. The problem is like, hey, human, do this. I'm like, all right, thanks, problem. So you group these, and you group these, and you see what comes out, yes? Okay. I like this problem. I would like this problem. Because there's 2 more steps until you're done factoring.
Oh, you got 3.
3 more, really, yes.
You got x squared on the left side.
Hmm?
So take this stuff out.
Oh yeah, sure. Take an x squared out, sure. Right. What comes out of these 2 here?
X squared.
X squared. And what's left?
X minus 4.
Yeah, x, and then I took the 2 x's, so minus 4. What can come out of these 2?
-25.
Yeah, negative 25, because you know you want this to have an x here, so it matches with this guy. So I gotta take a negative 25. So negative 25 divided by negative 25 is positive 1. 100 divided by negative 25 is
4.
negative 4. And how do I know I'm on the right track? These 2 are
The same.
the same. So 2 more steps and I'm done factoring, and then I can actually solve.
Like, moving 14 x minus 4.
Do it. Unless you've already done it, just sit there. How many terms are in this thing that we're looking at right now?
2.
Yeah, there's 1, 2. And they both have what?
X minus.
They both have x minus 4s, yes? So I can take an x minus 4 out. What am I left with?
X squared minus 25.
Yeah, you can literally do this. So I got x squared minus 25. Am I done factoring yet? Good Lord, Jeff. So then, x minus 4, how do you factor x squared minus 25?
X minus 5.
Yeah, this should be a think out problem, right? Can anyone tell me the 3 answers?
X equals.
Nah. I know you know. Anyone else tell me the 3 answers we get? Say again.
It's equal
4,
4.
yes?
It's equal
5, yes?
5. It's equal -5.
X equal negative 5, yeah. Once you got a factor, you can just see what makes each piece 0. If I can make each piece 0, then the whole thing is 0, and the equation is true. Okay, maybe. Remember? So try part D. So that's the answer to part B. Try part D. I like part D.
Is there supposed to be a backside to it?
What's that? I'm sorry?
Is there supposed to be a backside to this paper? Because
No. This is it. I'm pretty sure.
um,
No, wait. You're supposed to have a backside? Yes, you were supposed to have a backside. You didn't get a backside?
no.
Oh, man.
I'm so confused sometimes. I wasn't
backside. My printer likes to mess with me. It likes to remind me that humans are not in charge. Yeah, that's right. I forgot I was going to do that. It's okay. So one thing I forgot, listen, one thing I forgot to ask you is, if I had this equation, would I have to get it equal to 0? No, because all my x's are like terms, right? So it's only if I see powers on my x that are different from the other ones, so they're not like terms, I can't get them all in one place. So something interesting happens in this problem. So what's the first thing you do here?
Subtract.
Huh? Where should your eyes go first in an equation? Yes, multiply. What do you get?
3x minus squared.
Now, what do you notice about the x squares?
They're gonna cancel out.
So therefore, do I want to get this thing equal to 0? Hell no, there's no reason to now. The only reason we do that is if I have x values that aren't like terms, they have different powers on them, then I can't put them all together into one place. Here, they all have the same power, they're all the first power. I can just get them together, get the numbers on the other side, like in the olden days. And you get a semi-gross answer. Nothing too bad. Oh, that's funny. It's a good thing we're doing this one because I wanted to check. I didn't do this on the answer key. I think I ran out of room. So if you add x, and you add 4, then you divide by 4, you get a fraction, and you almost don't care because you're done. You don't have to do anything with it. It's just staring at you like, I have the answer. I'm like, thank you.
So back on B for 10, the one that we did previously, why do we get -4 and -5 instead of, or why do we get, x equals 4 and 5 and -5 instead of -4 and -5?
What value of, so I'm trying to make it equal to 0, right? So if I want to make it equal to 0, one of these numbers has to be 0, correct?
Right.
What makes this 0? What value of x makes this 0? Yeah. So x equals 4 is an answer. Yeah. So what's funny is, if you really wanted to, you can realize that's related to shifts. This would shift right 4, so it's positive 4. Positive 5, back 5, negative 5. Okay. You don't have to look at it like that though. It's just literally just what makes it 0. That's why it ends up being the opposite side. Yes?
We would do 8x.
I don't know. Oh yeah, sure. Let's see, let me get you out of here. So what's it mean to be perpendicular to another line?
Do at a right angle.
Sure, but how would I determine any information about the line that's perpendicular to this one? Alright, real quick. Two parallel lines, what's true about them? What do they have in common?
Same slope.
Same exact slope. Two perpendicular lines, one slope is going up, the other slope is going down. Opposite, completely opposite. Yes, does this sound at all familiar? Parallel slope, exactly the same. Perpendicular, totally opposite. So how do you make something opposite? You can change its sign, or you can flip it. So you do both. So if I only knew this dude's slope, I could then flip it and change his sign to find my slope. You can see that. My line's perpendicular to that one. If I knew his slope was 3, my slope is negative 1/3.
Right.
Flip it, change the sign. Do I know that guy's slope yet? How do I get this guy's slope? And that's making it look like it's a plus. It's a minus, all right, yes. I put a little dashed line here. How do I figure out this guy's slope? How do I solve for y? Yeah, if I solve for y, I'm putting it into what form? Y equals mx plus b. So whatever's in front of the x is going to be the slope, yes? So that's, perpendicular lines have completely opposite slopes. If I just knew that guy's slope, I could figure out my slope. How do I get that guy's slope? Solve for y. This is the steps you take when I give you this kind of problem. I need my line slope. So how do I solve this for y? At 5, and then divide by 3. Look at that y-intercept, isn't it gross? Poor little y. Do I give a shit? Nope. I just want my slope. What's this guy's slope? So what's my slope? If that guy's slope is 2/3, what's my slope? Negative 3/2. Change the sign, flip it. So if a line had a slope of -4, the perpendicular line would be positive 1/4. You just change the sign, flip it. Do I know the y-intercept? Damn it! I don't know the y-intercept. Do I know a point?
Yep.
Yep. So what can I use to get the equation of the line? Do I know the value of b? What would I need to be given to know the value of b? Because what does b represent? mx plus b. What does b represent? The y part of the y-intercept, yes? Did they give me the y-intercept? How do I know they didn't give me the y-intercept? Because what would have been true if they gave me the y-intercept? What would have been true about this point if it was the y-intercept? X would have been 0. Because that's how I get the y-intercept. Is x 0?
No.
Damn it! So then I can't use mx plus b because I don't know b. So what do I use instead? What's the other equation of the line? Oh shit, you got till tomorrow. Y minus y1 equals mx minus x squared. It's really just difference in the y's divided by difference in the x's, and we just multiply the x's out. So it really is just slope formula rewritten. Literally. And now I just plug all the stuff I know. Do I know m? Yes, we know m. Do I know x1, y1? Yes, because they gave me a point. I just plug all that stuff in.
Can we also go over number 6?
Oh yeah. So y minus the y piece equals x, I'm sorry, m times x minus the x piece. And then I can clean this up a bit. Distribute that, subtract 3, blah, blah, blah. Maybe. Do I need to have this memorized, Jeff? Hell yeah. Same way you got mx plus b. So I'm sorry, Ronnie, which one?
Number 6.
Oh yeah. Okay. Can anyone remind me
let's do this one step at a time. What test do I apply to tell if a function, if something is a function? I'm given a graph. What test do I apply to tell if it's a function? What test tells me if something is a function?
Straight line.
Vertical line test. So if every vertical line I can imagine only goes through once, most ones, it's a vertical, it's a function. How do I tell if it's an invertible function, also known as one-to-one? Horizontal line test. Would a parabola pass that horizontal line test? Would a horizontal line go through more than once? Bam, bam, yes. So much. Almost everyone I could imagine would go through more than once. So, let me show you something I haven't shown you yet. So here's x squared. I'll do it semi-decent here. So obviously it does not pass the horizontal line test. Goes through more than once, yes? Are you guys with me? Are you guys with me? Screw you, Jeff. Could I erase part of this and make it pass the horizontal line test? Two answers to what I'm about to ask you. What do you erase?
Well, negative on either side.
Yeah, either this side or that side. And what side do you think we normally erase? The negative side. That's why a square root cannot handle negative inputs. Because in order for it to exist, I have to cut the negative half of this off. This is so cool when this all comes back together. So, we created mathematics. If I want there to be an inverse function for this, all I do is I restrict the domain. I say y equals x squared for x greater than or equal to 0. I force it to only exist here. So then the new graph looks like this. 0, 0, 1, 1. Pew. Does that pass the horizontal line test?
Yes.
Hell yeah. So does it have an inverse? Yes, and in fact, if you flip it around that line, it's going to look like this. That's the square root, isn't it? Yeah. So that's why it lost the bottom half, because in order to make it exist, I had to chop half the damn thing off in the first place. Maybe? Screw you, Jeff. Oh, I just did the whole problem. Damn it. So if you restrict the domain to be greater than or equal to 0, then an inverse exists because it passes the horizontal line test. Later this semester, this idea is going to come back in a semi-big way when we do stuff with trigonometry. Ooh. Maybe? No? Yes? Maybe? No? Here, let me go ahead and give you guys the answer key so you can look it over. Also, let me say this. This is the first time you are ever getting a practice test answer from me. So don't do this. If you haven't done the practice test, don't do this. Yep. I would have done that. You're going to build false confidence. It's easy to agree with me. By the way, I do make mistakes. I'm averaging about a 97 on my answer keys. It's pretty good. So if you see them, you're like, I don't think it's right, you can ask me. I could have just had a brain fart. Who knows? You guys understand? So dear God, if you haven't tried to practice that test out at all, don't even look at this. But you can do what you want to once I give it to you. So just big suggestions. So just a couple quick things. Tomorrow, you'll have the whole time for the test. I'm not going to design it to take the whole time, but you will have the whole time. You all with me? So you'll have like 2 hours. You will be able to make corrections just like quizzes. Those will be due the day of the next test, like everything else almost, except for more corrections. There will be some bonus questions on there. You could technically make a 106 on each of my tests. And then the final is like 106 or 108, sometimes I'll put 4 bonus on there. You guys all with me? You don't have to do the bonus at all. You can just do them if you have time. You with me? Don't do them instead of doing something else, because they're not worth enough points. But they're a nice little bonus in case you're able to do them. What else? I don't know. I will have calculators in case you need to borrow any tomorrow. Is there anything else you guys want to talk about? Anything else? I feel like we've almost done every problem on here.
You mentioned that there are gonna be some problems, I think, where you don't want us to use a calculator for certain things.
Yeah, there are some tests. Not this first test. This first test I'm fine. But there are some tests where I'll have you a part 1 and a part 2. Especially when we get to trigonometry. In the final, I'm known to have a part 1 and part 2. But this test, you can use a calculator for the whole thing. But that doesn't mean you can do all the work on the calculator. I still need to see some work. You can just use a calculator for like basic little computations. Okay, maybe. Anything else? By the way, anytime we have a review day, if you are ready, don't get ahead out. That's fine. So if you have questions, ask away.
Mark.
Sue? Yes. Yeah, you have to find the perpendicular slope. You take the slope of the one line, you make it the total line, so change the sign. Yep. So I know one line slope, I know the perpendicular slope, it's just the negative reciprocal. Or like, change the sign, so. Don't forget about Christine's office hours.
On Thursday.
They were apparently erased at some point.
Thursdays, 5 to 10 p.m. to 6 p.m.
Oh shit, that's right, so we'll help you do that. Don't forget about my office hours. What's up? Oh yeah.